Welcome to another tutorial video regarding AB structures engineering. This time, I will be showing you how to solve for the quantity of cement in bags, sand and gravel in cubic meters for a post and footing, using the volume method and the combined linear meter method and area method. I will be solving this problem to show you how it is done. A concrete post 5 meters high with cross-sectional dimensions of 40 centimeters by 40 centimeters is supported by a footing slab 20 centimeters thick by 1.20 meters square. Using 40 kilograms cement and Class B concrete, find the quantity of cement, sand and gravel if there are 12 posts of the same size. But before that, don't forget to like, subscribe, and click the notification bell to support my channel grow. Structurally, post is always supported by slab called footing or foundation. Estimating the quantity of materials for these types of structures could be done by the volume method or the area and linear meter method combined for post and footing. In these problem, I will be showing you both the solutions for the two methods so that we can see how it is done. We first begin with our volume method. In volume method, we get the volume of the 12 posts since in the problem, it states that there are 12 posts of the same size. To solve for its volume, we have the formula, volume is equal to the sectional area times the height, multiplied to the number of posts. Substituting values, we have, volume is equal to the sectional area of 40 centimeters by 40 centimeters, converted to meter, and we have 0.40 by 0.40 meters, times the height of 5 meters, multiplied to the number of posts which is 12. We get the product and we have a volume of 9.6 cubic meters. After this, we will be solving the volume of the 12 footing slab. We have 12 footing slab because we also have 12 posts. We have, volume is equal to the number of the footing slab of 12, times the thickness of the footing slab of 20 centimeters, converted in meters to be 0.20, times the width of 1.20 meters and the length of 1.20 meters. We simply multiply and we have the volume of 3.456 cubic meters. After identifying the volume for the 12 posts and the 12 footing slab, we simply get the total volume by adding solved volume of each. Giving us, total volume is equal to 9.6 cubic meters plus 3.456 cubic meters. Giving us a total volume of 13.056 cubic meters. After solving the total volume, we multiply it to the corresponding values from the table. This table is the basis for all computations in the quantity of cement, sand and gravel if we are using the volume method. This table is from Max Fajardo's book named Estimate. Now, the problem requires a Class B mixture under 40 kilograms cement. We have a cement value of 7.5, sand of 0.50 and gravel of 1.0. We begin solving the value of our cement. We have the total volume of 13.056 times the cement value of 7.5. Giving us the quantity for cement to be 97.92 bags or say 98 bags. Next, the sand. We have the volume of 13.056 times the sand value of 0.50. Giving us a sand quantity of 6.528 cubic meters. Next, the gravel. We have the total volume of 13.056 multiplied to the gravel value of 1.0. Giving us a gravel quantity of 13.056 cubic meters. That is now the solution to our volume method. The next step is to use the combined linear meter method and area method, and let us see if we can obtain the same quantity of cement, sand and gravel. We begin by the linear meter method. Under this method, the length of the column is first determined. With the aid of table shown below, the materials required are found by multiplying the length by the corresponding values of cement, sand and gravel given in the table. These tables flashing in your screen right now is used to compute for the quantity of the cement, sand, and gravel if we are using the linear meter method. I have another video on how to solve problem using this method. Simply visit my channel to watch more. Going back with our figure. Our footing has a sectional area of 40 centimeters by 40 centimeters. We will be using this to locate the necessary values for our materials. Next, we locate the 40 centimeters by 40 centimeters size of our sectional area. Again, the problem requires us to use the Class B mixture under 40 kg cement. So we have a cement value of 1.200. The sand value of 0.080. The gravel value of 0.160. The next step we have to do is to solve for the total length of the 12 posts. To solve for the total length, we simply multiply the number of posts to the height of the post. Giving us, length is equal to the number of posts of 12 times the height of 5 meters. Giving us a total length of 60 meters. After getting the total length, we can now compute for the quantity of the materials. We begin with the cement. We have the total length of 60 meters times the cement value of 1.200. Giving us the quantity of cement to be 72 bags. Next, the sand. We have the total length of 60 meters times the sand value of 0.080. Giving us the sand quantity of 4.8 cubic meters. Next, the gravel. We have the total length of 60 meters times the gravel value of 0.160. Giving us the gravel quantity of 9.6 cubic meters. That is now the solution for our linear meter method. Next, we solve for the area method. Estimating concrete slab by the area method is much easier than the volume method. Now, we find the area of the footing slab. To solve for the area, we multiply the number of footings, which is 12, times the dimension of the footing to be 1.20 meters by 1.20 meters. We simply multiply, giving us an area of 17.28 square meters. After getting the area, we multiply it to the corresponding values from the table. The table flashed in your screen right now is the table necessary in solving for the value of cement, sand and gravel if we are using the area method. All the tables used in this video is from Max Fajardos's book named Estimate. In the problem, we are required to use the Class B mixture under 40 kg cement. In area method, we always take into account the thickness of our slab. Since our slab has 20 cm thickness, we will use this to locate for our necessary values. We have the cement value from Class B mixture under 40 kg cement to be 1.500. The sand value to be 0.100, and the gravel value to be 0.200. Now that we identified the values, we now proceed in solving the quantity of our materials. We begin with our cement. We have the area of 17.28 times 1.500, giving us the cement quantity to be 25.92 bags. Next, the sand. We have the area of 17.28 times the sand value of 0.1, giving us the quantity for our sand to be 1.728 cubic meters. Next, the gravel. We have the area of 17.28 times 0.2, giving us the gravel quantity of 3.456 cubic meters. That is now the solution to our area method. Our next step is to compute for the total quantity of our materials by adding the values we solved using the linear meter method and the area method. Again, we have the linear meter method. Next, the area meter method. Now, we add the values and we obtain the cement of 97.92 bags, or say 98 bags. The sand of 6.528 cubic meters, and the gravel of 13.056 cubic meters. That is now the solution to our combined linear meter method and the area method. Now, if you compare the values of our materials from the volume method, we obtained the same answer. Meaning, we can use any of the method in solving the materials for post and footing. That is now the solution to our problem. Don't forget to like, Subscribe and click the notification bell before you exit.